10 starships are on their way to Mars. There are no humans on board. 120 robots are hibernating on the starships, ready to start building and colonize Mars before the humans arrive. These 120 robots will first build structures to protect and fuel themselves. They will have to fight through dust storms, solar flares, hardware and software malfunctions, and the Arctic freezing Martian nights and winters. Once the robot settlement is established and they are protected, they can start Phase 2, building the Mars colony for the humans. The robots have 2 years and 2 months to complete their mission. This era is known as the Robotic Age of Mars, when the planet was inhabited solely by robots. The 10 starships land. The wake-up song plays throughout the rockets. 10 drones fly out of the rockets like bees out of a hive. They inspect the starships, looking for signs of damage from the landing. Inside the rockets, the robots are taking roll call. The robots establish network connections with each other, with the Starlink satellites in orbit and the rovers already on Mars, creating the first hive mind on the red planet. Because of the time delay in communications between Earth and Mars, the robots must work by themselves autonomously. Depending on the alignment of the 2 planets, it can take 3 to 21 minutes to send data one way. Mission control on Earth, the human handlers, adjust their sleep schedule to match Mars time, the working hours of the robots. Because a Mars day is longer than Earth, human mission control must shift their workdays 40 minutes later each day. The robots prepare to unload the cargo. Now begins the building of the robot habitats. The robots wait for 5:30 a.m. to strike on Mars, when the sun begins to rise and the surface starts to heat up. They will have 13 hours, until 6:30 p.m. when the sun begins to set and the freezing -70 Celsius, -94 Fahrenheit Martian night takes over. The robots can survive the nights, but more battery power is needed to keep the robots' hardware warm and prevent low-temperature faults. The robots transport the cargo out of the starships towards the base site. They are traveling around a mountain, 1.9 kilometers, 1.2 miles away from the landing site. Future rockets will land in the same area, and the base needs to be built far enough away to prevent kick-up of dust and rocks, and close enough to not waste energy. As the robots travel to the base site, the soil under them is compacted, creating the first roadway. Future landings will connect to this makeshift highway. First structure goes up. A large container is placed in the center of an empty dirt build site. It unfolds and the robots begin assembling the structure. It is a storage garage. Drones fly overhead working as surveyors. Mapping the building site, they function as mini GPS satellites, providing coordinates to the ground-based builder robots. The drones also carry cables across the structure. The storage garage is an enclosed shelter, but not pressurized as there is no need for robots. There is no radiation shielding either. The robots don't need much in terms of shelter, unlike humans. The new garage shelters the robots and protects sensitive cargo. It provides protection against cold nights and later in the mission, winter. It also protects the robots from dust storms. The garage also houses robots that clean the robot builders of Martian dust. Additional robots continue adding modules to the structure, upgrading it into a robot self-working workshop. The building is nicknamed Home Base. Away from the base, robots are deploying the solar field. Solar panels unfold and are brought to life. The solar panels themselves are robots, programmed to track and follow the sun during the day and year as the seasons change. They are able to generate more power than static non-tracking solar panels, meaning fewer solar panels are needed, covering less space and reducing the need for dust cleaning. Each solar panel has a robotic attachment that senses when the panel is covered in dust and cleans it. Smaller builder robots head back to home base to shelter for the cold night and begin data dumping. Larger robots, equipped with added insulation and onboard floodlights, continue to work throughout the cold night, unloading the robotic solar panels. All of the robots working to build the Mars colony can be grouped into 2 classes: dumb robots and AI machines. Dumb robots, such as transporters and miners, have very basic instructions. They follow a set path, going back and forth, loading and unloading materials. AI robots make decisions autonomously. These include manipulator robots with robotic arms and tool attachments. It takes 22 hours for a massive solar flare to reach Mars. The robot builders are put into sleep mode. A third of the robot's software becomes corrupt. They are shut down and rebooted. 2 ground-based satellites are set up to form the beginnings of a satellite field. A small dome is inflated to house the interior comms equipment. Control of communications moves from the Starships to the newly built ground station. This is the new headquarters overseeing the robots on Mars. The new comms dome connects with the Mars Starlink satellites and locally tracks weather, dust storms, and asteroids from the asteroid belt. Robots transmit their data dumps to the dome, where it is stored on servers and sent to Earth. In the future, the comms dome will track all incoming and outbound Starship rockets. Electricity from the new solar field is being sent to home base, where a battery bank stores the energy. There are 2 types of batteries, one for the dome buildings and facilities, and another for the robots. The robots use swappable batteries. Rather than having the robots take turns working shifts as one group recharges, batteries are hot swapped in the field. A charger robot carries multiple batteries from the battery bank to the building sites. There are also backpack rovers that carry and store less frequently used tool attachments to the building sites. This is more fuel efficient than having individual builder robots return to the main base to recharge and retool. The base begins to look like a town settlement. The entire site has been mapped by the drones. Roadways and paths have been digitally laid out. The robots have established a transportation network to move between and inside the structures. Inside the home base dome, the garage, 3 search and rescue rovers are parked, waiting for distress signals from other robots. They carry spare parts and use their robotic arm to repair other robots that have malfunctioned in the field. They search for robots that have gotten stuck in the terrain, needing to be towed out. They also clean other robots in the field, such as the solar panel cleaners when they themselves get covered in dust. And they perform inspections on structures that have possible damage. Robots deploy the first emergency dome. It is a fast-expanding, lightweight, temporary shelter, allowing robots to continue working during small dust storms. Robots work on finishing the construction of another building. This is the biodome, where plants are grown. Plants are needed early on in the robotic age, as the sugars from the plants are extracted to make a glue. When the glue is mixed with the regolith, the loose soil on Mars, it combines to make a 3D printing material. The robotic habitat printers will print large shells that act as radiation shields, a feature needed by humans. Inside these shells, habitat modules will inflate where the humans will live. Plants have been growing in stacks on board the Starships since the robots left Earth, overseen by human controllers on Earth using onboard robotics. The plants are transferred from the Starships into the newly built biodome. Inside the biodome, farming robots take care of the plants. They use their color recognition cameras to detect when the plants are ready for harvesting. Phase 1 is complete. The robot settlement has been built. The robots can survive and are self-sustaining on Mars, fixing, fueling, and sheltering themselves. They are the first to colonize Mars. The next phase is to build for their human overlords who are not as well suited for living on the Red Planet. The first human infrastructure buildings to be constructed are the life support systems. Oxygen, water, and more importantly, rocket fuel are needed. The humans won't be able to return home to Earth unless fuel is made on Mars. The robots have no plans on returning. Mining robots travel to mapped resource locations away from the home base. They collect ice samples for purity analysis, checking its suitability for production of human life support and rocket fuel. Back at home base, robots are unloading the structure modules for the refineries. Carbon capture towers are built to capture the CO2 in the Martian air. Electrolysis facilities are assembled to separate the hydrogen and oxygen from the ice water. A Sabatier reactor goes online to combine the CO2 with hydrogen to produce methane rocket fuel and oxygen. Ice mining droids travel back and forth between the ice fields and the intake docks at the base. In the future, a cargo starship will bring a small-scale flexible pipeline. The ice mining droids work throughout the night. Robots prepare the building site for the human habitats. The surface is flattened, rocks and debris cleared, and the surface graded. Large harvesting robots are out extracting soil near the base. They bring the soil back to a new 3D printing depot that has been built. A bioreactor purifies the soil of the harmful perchlorate. The purified soil is mixed with the plant glue and turned into a filament. It is stored, ready for the 3D habitat printer. The habitat printer is a large robotic arm. It slowly drives itself into place, fixes itself into the ground, and does not move until it is finished printing. The same tanker robots that will transport the fuel to the Starships are used to carry the 3D printing filament material out to the habitat printer. Connected shells are rising, forming a circle. The 3D printed shells create a makeshift cave system that will shield humans from radiation. Closer to the date of the human arrivals, habitat modules will unfold and self-inflate inside these shells, pressurized and oxygenated, ready for humans to move in. Inside the biodome, robots begin expanding the machinery to include planting and harvesting for human food consumption. Plants are grown under grow lights in trays stacked up high in a mini vertical farm to maximize numbers in the small space. A station with an iron ox robotic arm system plants seeds on trays and is able to monitor each plant for nutrient uptake and health status. The plants are tested for consumption purity and frozen for storage, creating the first pantry on Mars. Outside and away from the base, near the Starships, robot builders work on forming landing pads. Rovers flatten and melt the regolith, creating large flat surfaces. They reduce the kick-up of rocks and dust, increasing the safety of the next landings. Large HASSEL containers placed in the middle of the 3D printed shells unfold and self-inflate. These are the human habitats, pressurized and oxygenated with water and waste management systems. A small robot moves into the human habitat. This is its new home. The robot's onboard electronics and computer becomes the brain of the structure, turning it into part building, part computer. The brain monitors the habitat, the life support systems, and the surroundings. 3 humanoid robots are brought online. They are the Martian crash test dummies, testing out the habitats, EVA suits, and spacesuit and rover airlocks. Soon, the human tourists will be arriving. The robots are now casually exploring the landscape around the base, enjoying their freedom and spare time before the humans arrive. The humans will be weak from the 6-month journey in zero gravity. The robots will watch the humans as they navigate the dangers of Mars, the radiation, the harmful dust, and the freezing nights, before they return to the comforts of Earth in a year's time, leaving the robots behind to greet the next wave of humans.